Jeez. Okay, so to estimate the slope of the graph at the points x1, y1, x2, y2. So find the slope at this point and that point. We'll use the same ideas we did back in like high school math, right? Using the slope formula. Then eventually we start talking about. So here's the same deal. Finding the slope between that connects these 2 points. 5, 1, 5, 4. Make sure this is all right. So we're going to review basically the basics first. We're going to start with that. And then we're going to start talking about the derivative. And there is the limit process that helps you find it. The limits from the last chapter, which is the hard way to find the derivative. So I'll show you both the hard way and then the short way. So find the derivative by the limit process. So here they actually want you to use the limit process. Same thing here. So I'll do it once with the limit, and then I'll show you the shortcut. Okay. Now, the shortcut doesn't work on this one, number 8, because you need higher level techniques, which will be later in chapter 3. Okay. So I'll save that for later. But anyway, so if you saw the videos, you understand that the derivative at a point at any function. So once I find the derivative function, so let's call this f of x, right? F prime is the derivative. If you plug in any value into the derivative function, then you will get slopes. So because you see how right here the slope is horizontal, then down here it's negative, then up here it's positive, and the slopes keep on changing, right? So picture drawing a point and then drawing a line right next to it. Point, line, etc. Does that make sense? That's the whole idea of derivative slopes of the tangent line. Okay. So if you saw the video, I'm probably just repeating myself, but you see how this point has a tangent line, meaning a line right next to it. This line has a slope of 0 because it's horizontal. This is a positive slope. So they want us to find these slopes using the old method, and then we'll move on. So let's find the old school method real quick. So we're going to need these points. Can you tell what points those are?
First pair, x1 is 1, y1 is 0.5.
So for this one, x1 is with this guy? Is that what you're talking about? Or this one?
Negative. The second one, right?
Let's see, the one on the, I said x1, so the one they labeled x1 is 0.5 and x2 is 1.
Yeah, so it did say estimate because these points are not pretty. You can already tell, right? Although we should know that slopes of horizontal lines are 0. So this one, that's already a 0 even without doing any work. That should be something you remember because there is no increasing or decreasing. It's constant. Over here, it is increasing. So this one will be a positive slope. Okay, so we will find the slope for this guy. So let's estimate it to be at 1 and 0 instead of 0.99, whatever that is, right? See what I mean?
Couldn't we just pick other lines on the point, like where we see intersections? They'll still give us the same slope, right?
Pick other points? What do you say that again?
Yeah, so like the tangent line, like if we went -1, -2.
-1, -2.
Where it looks like it's crossing really close to an actual intersection.
Yeah,
and then
you
maybe
could.
like 1.5.
As long as I'm on the line, yes. But I think nowhere on the line do I see a pretty one. This one, I guess. Oh, you're talking about this point, right? Yeah, that's the
like
only
so where
nice
That's-
point that
it's
I
like
see.
clean.
Yeah, that'd be negative 0.5, -2.
Yeah.
-0.5. The next time you get another full one will be -1, -3.
So if this is okay, let's try that out. So using the idea of rise over run, if this is -1, -2, how far is this point? So that'd be a rise of 1, right? And a run of 1.5.
Uh,
About, right? Let me write this down. So graphically, we would go from, you said -2, -1. Sorry, no, change in a second.
I think we had a mistake here because the it's graded in half marks. Double check your gradations.
Yes. So this is a half right here, right?
Yep.
Oh,
So
quarter, I guess.
yeah, -2 would be a half.
Yeah. So
That line's a half.
1/1.25. So 1.25, right?
Mm-hmm.
Yeah.
Let's say.
Well, let me write the points down first, so I don't get them all mixed up.
Okay. Yeah. I'm sorry.
Okay. So we're going up to negative. Going up to -1 on the y, and the x value will be we said about 0.25, right?
Yep.
Okay, so we should remember that slope is equal to, let me switch over now that I have that down. Slope should be rise over run, which is equal to a difference of what? 1 over, how much did my x change? Or from -1 to 0.5. How far is that?
1.25. That should be 1.25.
Right. So roughly, what is that?
What?
0.8.
What is it?
0.8. Is it 0.8 or no?
Let's see. Looks like it's close.
Doing the division, yeah, 0.8.
No, I'm in student version. It won't let me click anything. Hold up. Let me change. Okay, that's cow 1, 3, 1. Yeah, here we go. Sadly, I lost the problem. Oh well. But anyway, the question really is just about estimation. Since there's not much numbers to crunch, this one's a little easier. It randomly generated another one. This is still 0, of course. This guy, I think, is a different spot now, right? Or is it the same? I don't remember.
It looks about the same.
Because over here we were at -2, -1, right? Last time.
This one's different.
Yeah, so it's not the same place. So this guy looks like it's almost on the 1, 0. So you would have to estimate roughly -3, 0, and then do a rise over run to 1, 0.
So like what I was trying to get at, couldn't we go like x equals -1 and like x equals 2.5? Because they're close to intersections along the grid that would give us a more accurate estimation.
-1 and 2.5, you said?
Yeah, like just for an example. So it looks like -1 is -4, -1 y value is -4, or -0.5, sorry.
So here's -1 on the x, and on which
I mean,
y?
-0.5, sorry. -0.5 is -4.
Yes.
And then like, let's say, for example, we went to x equals 2.5, and that would give us 3.5. Because
Yeah,
it
you're
looks like
saying
they
go from here to here, or a different one?
on the positive side, like x equals 2.5. Just to give us a stronger,
Yeah,
because of
I
the
mean, it doesn't matter
intersections.
how you do it, as long as you choose a point and you count the units to the other point. Yeah, I'm just picking random points. But yeah, this is a good one. You can use this guy and then another point. That would be fine. So you're gonna get close to 2.5.
What's the margin of error, like a plus or minus on these two?
I can increase or decrease the tolerance, and I'll check because I don't want this to become an annoying problem. It's supposed to be just more of a concept, not a frustrating question. But yeah, you could do it the way you said. That's fine. But I will check that because otherwise I'm going to remove it because that's not fun.
I'm sorry, can you repeat that? I guess I'm just lost altogether with that one.
Yeah, you know what? Let me draw you a pretty function that's a lot easier. Here, hold on. Let me find one. Give me one moment. Right, so f of 4 means plug in 4 and see what you get. Well, we already have the point, so it's 5. That's what they're saying. Plug in 2 into the function, you get 3. So it's actually 5 minus 3 for the y values, and the x values are 4 minus 2. So going back to high school algebra, we had this notation. College algebra, and maybe before that, we had functional notation. Okay, so they're asking, is this bigger than, is this guy? Go back to the question here. Which slope is bigger? This slope or this slope? Okay. So 4 and 2, that's these x values here.
Second one.
Over here we have 4 and 3. So where is this point here? 3 is right here, and that x value, y value would be 4. So 3, 4. So is this slope bigger than this slope? Let me make a mark right there. Right here. So they're asking you, is this one bigger or this one? That's what they're saying. Which one's steeper? Probably a better way to say this. Because if the slope is bigger, that means there's a faster increase. So right here, you see that it's increasing faster than it's starting to level off, right? You see that?
Mm-hmm.
So this guy should be slower than this slope. So it's faster, slower, and more slow. So the biggest slope will be this guy, meaning, because it all comes back to what we're in the theory in the videos, right? A slope is a rate of change. So a slope at any given point is the rate of increase of that function at that x value. So it makes sense that this slope, which is this formula right here, is faster than this slope, which is this one. That's why they put this one's this is greater than this. What they're really saying, right? If you answer everything to make it more simple, because the notation might look confusing if you don't remember. So what they're really saying is the slope, just putting it in plain English, right? Is the slope of these 2 points two comma 3 and 4, 5 bigger, or I guess greater or less than, I should use normal math language here. Greater or less than 4, 2, 3, 4. Three is 2y2. I'll have to look at the value in a second. I should do it the other way, sorry. Can I rewrite the question for you so it makes more sense? And we said at 3, it was pretty much 4, right? Okay. Now I got my thoughts together finally. Sorry about that. Okay, so is the slope of these 2 points, 2, 3, and 4, 5, greater or less than the slope of 3, 4, and 4, 5? That is what the question is saying. So back to the picture. Now we got everything we need. So here's this point. So if I find the slope between these 2 points and these 2 points, which one is bigger? That is all they are saying. Does that make sense? It's just, I feel like they overcomplicated this when it didn't need to be. So just find the slopes and then compare them. But when you do the notation, the f of 4, f of 3, you need to find the y values on the graph. That's it. Does that make sense? I was trying to find a better way to explain this question. Sorry if I was confusing at first. You guys have any questions on number 2 before I start to show you the shortcuts?
I understand.
No, let's do 3. Can we?
What's that? Sorry, my volume was low.
Can we do 3? Number 3?
Yeah, let's move on then. You guys don't have questions. All right, number 3 is find the slope of the tangent line. So basically, we need to graph it so we can see what's going on here. Can you see the graph?
No, I can't.
No. All right, let me put the share the graph really quick. Okay. You can see it? Or no?
Yeah.
Okay.
No, let me see it.
So we're going to put this guy in here, 3/4 x plus 3. And that's just a basic line, right? You guys remember? There's an intercept right there and here. And it asks us, what is the slope of the tangent line at this specific point? So basically, you have to go to the point -4, 0, and find out what's the slope of the line here. But since it's a basic line, the slope doesn't change, does it? So the slope would always be the same. It's just 3/4, right? But let's pretend it wasn't that easy. Let's pretend we didn't know what the hell's going on. So let me show you this idea called the power rule. So we can try to start doing some shortcuts here. So the power rule works this way. So if you have a function equal to x to the n, and you want the derivative, which will tell you the slopes at any given point, all you got to do is bring the n down in front, whatever number that is, and then subtract 1 from the power. That's the rule. So, for example, if you had f of x equal to, let's say, 2x squared, the derivative would simply be 2, and then you bring that 2 down. So now there's 2 2's. 2 minus 1. So you get 4x. You see what I'm saying? So now any point that I choose on this function will give me the slopes at any location on this parabola. Okay. So if we go back to this specific function, it says find the slope of the tangent line at -4, 0 of f of x, or maybe they said y, I don't remember, 3/4 x plus 3. So the derivative is what you got to find first. When there is no power on here, it's basically going to disappear. So this is what happens. So if you have a first power, you subtract by 1, right? Then you bring down the 1, but bringing down the 1 wouldn't do anything, would it? Right? It would just be 1 times 3/4. Now, the derivative of a constant is 0 because it's constant. Derivatives is about rates and changes. This doesn't change. A variable changes. So whenever you're doing a derivative of a constant, it will always be 0. And we'll go into more detail about this. So now you're going to end up with 3/4 x to the 0, and anything to the 0 is 1, meaning your derivative is actually just the slope because it's a basic line. So it's not that interesting. So we're going to do this on a harder question, so it makes a little bit more sense. But back to this specific question. So they're asking you, what is the slope of the tangent line at this location? Well, it's just that same slope because it is a basic line. Now this one is different. Here we have a power and a constant. So the derivative of this, we'll have to do the power rule. And once we find that function, we're going to plug in 3. And that will give us the slope. That's all you got to do. So find the derivative, plug in the number, and you're good. Okay. So let's do that. So number 4. Let me write the question down. Find the slope of the tangent line. There's a bunch of these, so we'll keep doing it until it makes sense. And I'm just going to abbreviate the question so it makes more sense. So find the slope of the tangent line at 3,11 of...
You're still sharing your other screen, not the...
Yeah, let's switch as soon as I'm done writing.
Oh, okay.
so I can see it. Okay. Sorry about that. Okay, so do you guys remember from the videos what tangent line means? What is a tangent line? Well, let me graph it for you if you don't remember. 1 second. All right. So just in case you forgot to watch it because you're partying all week. All right, let's see here. 2x squared plus 7. This is the function they're asking about. We'll call it f of x instead to keep consistent. What the hell? Stupid fat fingers. There we go. All right, so here's my function. So they're asking what is the slope of the tangent line at the location 3, 11. So let me create the point 3, 11. Okay. Let me double check. I wrote that correctly. Find the slope of the tangent line to graph the function at the given point. Okay. Two x squared plus 7.
Have it's
minus
minus 7.
I'm like, something is wrong here. There we go. It's like, why is it off to the side? Sorry. All right. So this is the idea, right? So there's a point, 311, and they want to know what is the slope going through this point. Tangent meaning right next to the graph. So if you're right next to it, what is that slope? All right. If you zoom in, you can tell it's positive, right? Because it's increasing. Yeah. All right. Well, what is it? That's what they mean by tangent, meaning if I drew a line right next to it, tangent to the point, what would be that slope? That's what they're asking. So in the video, what they do is they pick 2 points and then they decrease that distance between the 2 points until it's infinitely small and it zeroes into just 1 point. Meaning you can find the derivative, find the slope of any point along the function. So any point anywhere, I can find the slope. So slope here, all here, there. The slope here would be 0 because it's horizontal. Slope going down this way would be negative, and as soon as I round this curve, it becomes positive, and all the slopes are different at different rates. So some are faster, slower, negative, or 0, depending on the function. So they want to know what's the slope here. In other words, what is the rate of increase at this location, 311? That's what the question is asking. How fast am I going at this spot on this graph? In normal English, right? That's what they want to know. So let's do it. So in order to do so, you need to find the derivative. So f prime of x, we use the power rule. So we bring down the 2 and subtract 1. And this is a minus. And that becomes a 0 because it's a constant. Okay. So that would become what? 4x, right?
Mm-hmm.
So plug in 3, because this new function that we created tells you the slopes at any location on the graph. So they want to know what's going on at 3 to plug in 3. So the slope at 3 is 12. So the slope, put this in English so we remember, the slope of the line that is tangent to 311 is 12. 12. 4 times 3. Does that make sense?
Yes, but I have a quick question. What was the name of that power rule?
It's which rule
The one that we just used?
for the derivative?
Yes.
It's called the power rule for derivatives.
Okay.
It's the first thing you learn when you start doing derivatives, and then we're gonna have a bunch of different rules, but that's the first one. So I'll put it up top here. The power rule is when you have f equal to x to the n, f prime is equal to n times x to the n minus 1. Now, constant rule. If f is equal to some number, that's an ugly pound sign there, the derivative is equal to 0. Okay.
Got it.
Okay. And we're going to go into much more detail in the next section for derivatives. I'm trying to show it to you now, like a brief, quick example. That way, these will be easier. Because in the video, you're going to see that they're going to use limits to find this value, this function for x, which is a lot of steps. So if you look at this, they say find the derivative of the function by the limit process. So I'd have to do it here, but you already know, right? The derivative of any number is 0 because it's a constant. So we don't have to do anything. So we can avoid this. And over here, if we find the derivative function, which it didn't ask us to do, but we did it, plugging in that number 3 into the derivative gives us the answer, 12. So it's an easier approach to these questions because that's what you're going to be doing anyway in the next section. Okay. Now, do you remember the difference quotient back in college algebra?
Somewhat.
It was like f of x plus, or f of x plus h thing. You remember?
Yep.
So basically what they do is they use that formula, take a limit, and that limit becomes the derivative. So in order to avoid doing that, you can use the power rule here, right? Now I'm going to do it both ways so you can appreciate this. Hold on, let me find it. Where is it? Yeah, here it is. Okay. So this is number 6. So I'm going to show you the limit process for this question here. The answer is 2x plus 1, but who cares about that? The question, what matters is how do we get there, and why is that? To find the derivative using the limit process. So here is the function f of x, x squared plus x minus 8. So you have to use this formula. You got to take the limit as x approaches, as h approaches 0 of f of x plus h minus f of x over h. So you find this difference quotient, then you take the limit and you will get the derivative automatically. So we first got to find what the heck is f of x plus h. We know what f is, right? So that's easy. That's this. So let's keep going here. So the limit, as h approaches 0, you got to plug in f of x plus h. So f of x plus h means you're going to plug in x plus h at each single x value and then simplify. So you're going to get x plus h squared plus x plus h minus 8, right?
Yes.
Minus f of x, which is x squared plus x minus 8. Do you agree with this so far? You see where this came from? All right, so we're going to have to expand this and distribute the negative and cancel like terms. So squaring this would give us, let's see, let me put a giant bar here. X squared plus 2xh plus h squared plus x plus h minus 8 minus x squared minus x plus 8. There you go. I'll just do the algebra for you there. So now the x squares will cancel, the x's will cancel, and the 8's will cancel, right? That will leave me with so x's are gone. Leave me with 2xh plus h squared over h. Do you agree with that algebra? Do you see it? So at this point, you can almost take the limit. My pen's dying here. It's getting lighter and lighter.
Fine.
Try this one. I've been meaning to go to campus and pick up supplies, but I keep forgetting to sign up. It'll go Friday.
You say that now.
Albert's forcing me.
Ah, good.
I was supposed to go like 4 weeks ago, and I haven't gone.
Yeah, I busted his shop. I busted Albert's chops earlier. That was funny.
Oh, you did you? When did you see him?
Oh, my mom's in his class.
Oh, nice.
I woke up right around the time they were ending class, so I walked in around the time they were ending class, and I got to we wound up busting Albert's chops. He said him and Renita run the joint. George is just sitting there as a pretty boy. He's an ornament.
I have a question. What happened to
what's
the
up, man?
h in the so on the one above the x squared plus 2xh plus h2? I see all the other stuff canceling, but what happened to that h just to the right of your pen?
Oh, this h. Yeah, that's still there. Thank you. Yeah, because this
Okay.
doesn't cancel. None of the stuff, nothing with h cancels. Only the x terms cancel. Okay,
And
thanks.
First x, is it x squared or x1?
Here?
Right below it.
This is x squared.
Okay.
So you multiply and expand this, and you get these three terms. And this x plus h is right here, minus 8. And then you distribute the negative, you get these three. And then stuff cancels, and we get to here. Now factor the h, and you get 2x plus h plus 1 over h. So you see how these h's will cancel, right?
Mm-hmm.
So now you can take the limit. What is the limit? What happens if you let h go to 0?
Plus 1.
Yeah. You get the derivative. So f prime of x is equal to 2x plus 1. Do you agree that that's kind of long, right?
Yeah.
So the power rule that I showed you allows you to skip all this and get to here right away. So let's do it the other way so you can see what I'm saying. So same question, number 6. Find the derivative. I'm just gonna write whatever because we did this already. F of x equal to x squared, and I'll put the other page back in a moment if you need it. So if you take the derivative, use the power rule on the first one, right? That means you bring down the 2 and you subtract 1, right?
Mhm.
On this one, you bring down the 1, which doesn't do anything, and you subtract 1. And this becomes a 0. So this becomes 2x. This becomes 1 times x to the 0, which is 2x plus 1. Do you see how it's the same answer?
Hmm.
So this is the shortcut I'm trying to show you, and I'm trying to show you why it's awesome,
Can you
because
put it back, please? A little bit. Sorry.
this one is a lot longer. So I'm not gonna make you do this all the time. I might make you do it once. That's it. But I would prefer you do it the other way every single time.
Can you put back the paper, the shorter version?
Everybody got this page before I move on?
Just one quick question. So
Mhm.
I know the h's cancel out, but
Yeah.
what happens to that h in the middle, the 2x plus h plus 1?
You
How
let
do we
h
get
go
rid
to
of that?
0 at this point.
Oh, okay.
So you take the limit and then you find the derivative.
Okay.
So the theory, the whole reason we even learn limits is to be able to create the derivative, because without limits, you cannot shrink the distance between 2 points into infinitely, into 0 using infinitely ideas. And once you do that, you can use this.
Okay. Because essentially that would be, we would just continue to move the secant line until we hit the tangent, right?
Yeah,
By
pretty
shrinking it.
much. Yeah, you have like the average of 2 slopes, and you shrink it the distance between them until it becomes a single point.
Where'd you get 2x from?
So the original is right here, right? X squared plus x minus 8.
Mhm.
So you bring the 2 down. That's the
Oh.
power rule. And then you subtract 1 from the power, gets you to 2x.
So what do we do with the -8?
The derivative of a constant will always be 0. So see, the derivative of the first one is 2x. Derivative of the other one is 1. Derivative of the constant is 0. So 2x plus 1 plus 0.
Okay, that makes sense. I got it.
Is the power rule making sense?
Yeah.
Yes, you will accept this shorter version, right?
Yeah.
Oh, it'll work.
Only because I like you. So this right here, right? Let me hide these answers if I can.
Well, we all have different questions, so it
No, I know, but I want you to do it in your head. Can you see it?
Can you
The
show
bottom
us the
part?
shorter part again when you get a chance?
Yeah, I'm gonna do it on this one real quick. So can you see the bottom function or no? I'm hoping you can't see the answer, but if you can, oh well. Do you
Okay.
see what the derivative would be here for the first term? Right.
Yeah.
So the square,
Yeah, you bring the 3 down, right? So it'd be 12x squared. You subtract 1, so it becomes a 2. And this guy would be,
3.
you bring the 2
four
down.
x.
Yeah, 4x. So let's do that. So you see how that's super easy, right? Find the derivative. When I say easy, I mean compared to the limit way. Find the derivative. I don't like to say things are easy. Find the derivative of the function. So they say use the limit process, right? So we will not do that. But I did it once for you, so you know what it looks like. So the derivative, showing all our steps, would be you bring the 3 down, you subtract 1, and then you bring the 2 down, and you subtract 1. So that would be 4 times 3, 3 minus 1, 2 times 2, 2 minus 1. Do you follow all the steps? Or does anyone not follow it? I guess is probably a better question.
But you said you dropped number 3 down, right? In the beginning.
Yeah, so that 4 was already there, right? That's this 4. This 3 comes down to,
Oh, okay.
to multiply the 4.
Okay.
And you subtract 1, giving you a 2. This 2 was already here. So you brought down this 2. That's why we have 2 of them. Subtract 1. Now we have a first power.
Eso va a servir para todos los números. Is that going to work for all numbers?
It will work for all functions that look like this.
Okay.
It will not work for number 8. Not without learning more techniques. So the power rule doesn't work on this one. You will need to use the limit process or more advanced derivative techniques. Same with this, you would have to do limit process without fancy techniques, which we will talk about in the next section. So for these, I'm going to make you do it with the limit. But the rest, you don't have to.
Okay, so for that one, we're going to have to do the limit.
This one, yeah.
What about the other ones? It's just that one?
So as long as they look like polynomials, see how they're just x squares or x's or whatever?
Yeah, that one.
Those you can do power rule. So all of these, this one, all of them except this guy. It's that you have to do limit. That's the only time they force you. But once you learn more techniques, you will never have to. We just got to get there. We need to go a couple more sections. Okay. Let me see here.
I'm sorry. Can you show me the power rule one more time? I just want to make sure I copied it right.
Yeah. You want to do a different one? Or the one we just did?
I just want to know, is it always going to be -1?
Yes.
Okay. So we're just, okay.
So you whatever number is there, you bring it down in front, and you do -1 to the power.
Okay. Yeah, okay.
Okay. Today is Wednesday, right? Yeah.
Okay. 10th.
All right. Now let me pick a next question. Equation line to the graph. Now let's do 10. So if they said find an equation of the line that is tangent to the graph. So I need to find, so here we need to find an actual equation of a line, not just the slope. This requires more work. And not only that, it also needs to be parallel to this one. So there's two things going on here. So find the equation of a line that is tangent to the graph and parallel to the given line. Okay. So do you guys remember what it means to be parallel for two lines?
Yeah.
Like visually, I'm assuming you know, but what about the slopes? What happens to the slopes if they're parallel?
Aren't they the same?
Yeah,
Constant.
they have to be the same, right? So if you have two lines that are parallel, then that means by definition the slopes must be equal. So meaning if you find the slope of this line, then you know the slope of the tangent line because it needs to be parallel. So solve for y and you'll know the slope, right? Move this y over and you'll have your equation. Then all you got to do is find the intercept. So let's try to work through that. Let's see here. This is number 10. I'll switch over. One second. Okay. Yeah, this is still a little challenging, but that's okay. Find an equation I'll just take some different numbers here of the line that is tangent to the graph of f and parallel to the given line. And here is the line. I'm going to use this one here so I can check my work. All right. So if you solve for y, you can see that it's going to be, if you add the y over, right, you would have this here, which you can rewrite as just simply y equals 4x plus 4. So the slope is 4, right? So now, if we take the derivative of the function, that would be 2x. So, oops, where did that thing go? So we know that the derivative must be equal to 4, slope. So we need to now that if we set it equal to 4, then we can solve for the x value, which will then allow us to find the y value. Because we know that derivatives gives us slopes. Okay. So we know that the derivative at some value needs to equal to 4. I don't know what x that is, or what y value that is, but we can solve for it. So if we solve for x, we can see that x would be equal to 2. So when x is 2, then we have an equal slope. Because if I plug in 2, you see that you get 4, right?
Mhm.
So we just need to find a location. Okay, well, what is the y value if I plug it into the original? What is f of 2?
Would be 4.
Yeah, so we need that point in order to do any work. So they made this question harder because we don't have that point. So we have to use these clues to find 2. But this part is kind of, I feel it's a little confusing the way they do it, but I'm trying to make sure you guys are still following me here. Do you see why this is 4? Number 1.
Yes.
Okay. So, and we agree that in order, if I want the tangent line to be parallel to this line, they must have the same slope, right?
Mm-hmm.
By definition. So I'm going to set the derivative equal to 4 because that is the requirement, because the derivative gives you slopes. Slopes is specifically the slopes of the tangent line of the original function. So now I have the x value. I can use the line equation from back in the day to find the line that they're asking for. So use this guy. So once you have the x and y value, and of course the slope, use this formula. It's a y minus y1 equal to m times x minus x1. Do you remember this?
Somewhat.
It was back in, this was the high school days or developmental days. Maybe you reviewed this in college algebra.
Mm-hmm.
It was a long time ago. But
No
basically,
matter how you place it.
yeah. So no matter what, you use the slope and a point, and then you can answer their question. We know that they want the slope has to be 4 to satisfy their condition of it being parallel. Okay. The hard part, that's the easy part, right? Because we already knew this right away. The hard part is figuring out what the heck is the x and y. So that's why I had to do this. So I set the derivative equal to 4 and solve for the x that makes it true. Which x value makes it 4? Well, I can see right away, right? 2 makes it 4. So once you have 2, plug it into the original and you'll know what the y value is. So the point that you need, use this point. 2, 4. So they did not give this. If they would have given this to us, this question would have been much easier, but they didn't. So you need to figure out the x. And once you have the x, you plug it into the original and you get the y. So now all you got to do is use a formula. So y minus 4 is equal to 4 times x minus 2. Solve for y and you end up with y equal to 4x minus 8 plus 4, which finally becomes 4x minus 4. So this is the tangent line that is parallel to their line, which is this guy up here. So there's a lot of ideas from a while back that makes this question harder than it needs to be.
So the answer for number 10 will be y equals 4x minus 4.
Yeah, that's what they're asking for. And let me show you the.
Question.
Mhm.
So you brought the square down, right? So I made it 2x.
Mhm.
Okay, so what if the f of x was already 2x squared? That would become 4.
Right, 4x.
Okay, and we don't have to, you know how like on the line it has like a 4x already, but we have to add those or no?
This line?
Yeah, like you see how it says 4x minus y? Will we have to add the 4x or no?
Yeah. No, actually, no. All I did was I added the y over here, and then I just flipped it over. See how this is the same?
Do you get what I'm saying though?
I didn't add the 4x.
Okay.
I just rewrote the question because the y is over here, so I wrote the y over there. This I just wrote over here. You see what I mean?
Yeah, because on number 11, for mine it's f of x, but it's actually 2x squared, not just x squared. That's why.
Oh, you're
Talking
doing
about
question
this guy?
10.
Yeah, no, on question 11.
Oh, on 11.
Mm-hmm.
Let me see.
Yeah, that only works if it's x squared.
No, it'd be the same thing. You would just set it equal to 4x. But you first have to solve for y. This process will be exactly the same for that question.
Okay.
Are you having issues solving for y on the line?
I'm sorry.
Did you have problems solving for y or on number 11 or what happened?
I just got confused with the 2x squared, and if I had to add, like with the line, because you know how it has, for mine it's 6x. So I don't know if I was supposed to add that, like, or multiply it or something.
No, you just solve for y any way you want. As long as y is isolated, you can then identify the slope. So get to here however you want to do it.
Okay.
So you start here and solve for y. Once you do that, you have your slope. You set this equal to this 4 or whatever slope you get equal to the derivative. Your derivative would be 4x. So you'd have 4x equal to whatever the heck you got here for your slope.
Yeah.
And then you solve for x, and once you have that x, you plug it into the original, which is 2x squared on your end, and you have this point. Once you have that, you can answer the question, because that's all you really need. You need the point and the slope. After that, it's no big deal. But finding that point, I think, is the hard part. Let me try to visualize this for you guys. Okay, so what they're asking, right? So they have a problem, and they give us a line, 4x plus 4. There's just no worries on the solving. So they want to know what is a tangent line to this function. So some line that's tangent to any point somewhere, I don't know where, that is also parallel to this guy. So you got to find that point. And we found it at 2, 4. So 2, 4. It's right there. You can see that if I drew a slope through here, it would be parallel to this line, right?
Mm-hmm.
That's what we're looking for. What is the equation that goes through here? Because that would force it to be parallel. That's what we're doing. But in order to do so, we need the x and y value. Once we have that, you can find the equation, because to find the equation, all you need is an x, a y, and a slope. And we know the slope has to be 4 because it needs to satisfy the parallel idea, right? So there's a lot of ideas at the same time in this question because it's forcing you to go back to what does parallel mean? What are derivatives? What the heck is a tangent line? And then how do I solve for a line of an equation? So there's a lot of stuff from back then mixed in with new stuff. So if you feel like it's confusing, that's the reason. And I'll send you more examples. I'll do another one just in case, but let me show you how they did it.
How did you get 2 again?
Oh, just divide both sides by 2.
Okay. And
Once you have that, you plug it into here.
okay. All
That
right.
gives you 4. So here's the solution that I pulled out from the question itself. I don't think it's very helpful, but so they used the limit definition. So they took the long route to find this, which that's a real pain. And we know the slope has to be 4 because it has to be parallel. So you solve for y, and that's why they knew it's 4. So they don't even tell you why in the explanation. So then you set that equal to the derivative, and you solve for x. Once you have the x, right, you plug that x into the original, and they get the point. So they don't explain that either. But once they have this and the slope, they just plug it in. So you see how that's not very clear, right? So I want to make sure that I showed you more details than they're going to show you. Is there any questions at any point on this problem? At any part?
No. But I did have questions on 11. So.
All right. Let's do 11. We'll do it again. It's the same deal, so we'll do it one more time so we can try to grasp what the heck is going on.
Oh, you see, it says 0.5. I don't know where they're getting that from.
They solve for the line equation. So, do you have the same numbers or no? Is it different?
It's different.
Oh well, just I guess just adjust it. I guess. Okay, so find. Let me write the question down. Find an equation of the tangent line that is parallel to the given line. I'm just going to paraphrase because it's the same question. Okay. Yeah, no worries, Krishan.
Yeah.
No big deal. I know it's late. Okay, so f of x is equal to 2x squared. So the first thing we need is the derivative, which you said, Suleika, that is 4x, right?
Yes.
Now we have this line. So we need to solve for y. So I'm going to add the y over to the right. So plus y. That gets me to here. 2x plus 5 is equal to y, which means that y is equal to 2x plus 5, right? Same thing.
Yeah.
So in order for me to find the parallel line, the slopes must be equal. So I need to use that idea to figure out what the heck the x value is. So I set the derivative equal to that slope. You solve for x, which gives you 1/2, right? So we have the x value, plug that into the function. So f of 1/2 would give me the y value. So 2 times 1/2 squared would be what? 1/4 times 2. Is that
So
half again?
can you real quick say how did you get x equals 1/2? Real quick.
Oh, sure, yeah. So just divide both sides by 4. So what is 2 divided by 4?
1/2.
That's 1/2. But where'd you get the 2 then?
Which one?
The 2 is the slope on the y line. The y
Yeah, I
is
need to
equal to x
use,
plus
it's
1.
coming from here, yeah.
So basically, that 2x is your slope.
Yeah. Remember when you find slopes for lines, right? You look at the number on the x. Do you remember? So whatever's on the x is the slope once you have solved for y. That's why I knew it was 2. So once you have this, you set it equal to the derivative. You solve for x, and you plug that into the original function. So now I have the y value. So to answer the question, right, to find the line they want, the line equation, you need 1/2, comma, 1/2, and a slope. So you need a point and a slope. So all this work was to find the point, honestly, because the slope is the only thing that's somewhat obvious because they told us it's parallel. So if I remember what parallel means, the slope will be easy to find. So once you have that, you use your formula for a line, and you find it. So plug in the x and y. Plug in the x. Distribute your 2. Add the 1/2 over, and we're done. I skipped some of the algebra steps because this stuff is not new, but if you need me to go over it, I will. I want to make sure you get this part though, in the beginning. That's the new stuff. Is there any questions from the beginning or anywhere at the algebra steps?
Not really.
I know you're all tired, but
Yeah.
all right. All right, guys. I'll let you digest this and think about it. It is getting late, so I want you to watch the videos, go over the homework afterward, and then bring some questions for me on, I guess Monday, huh? Let me see.
Will you open up the 3-1 videos?
They should be. Let me double check though.
They were closed.
There, man.
For real?
Mhm.
Oh, I know you messaged me. Is that what you're talking about, Felipe, earlier? She's the thing he left.
No, it was 2.5, the one that I didn't do. It's already closed.
Let's see. No, it's open. Module week 5. Right
Yeah, you just
after the
have to.
test, as you
Yeah,
see the 3-1. Oh, you know what? You can't see these because you haven't done the test. Is that what it is?
yeah, you have to do the test to be able to see the videos.
Okay, that's what it is.
Or at the very least, you have to go through the test. You at least have, or not, you have to at least go through the module. You have to click through, right through the module using that next button to get to it. So you start on like the test 1 information, click next, and you find yourself on the paperwork upload. You click next, find yourself at the test, and you click next, and you find yourself at the first set of videos.
Yeah, you should probably focus on getting that test done first
I recommend it.
before we get too deep into derivatives.
Mm-hmm.
When test closes, when 15th, I think I said.
Yeah.
So yeah. So on Monday.
You move it to Monday?
Yeah.
Okay.
So I'll move the I move the exam to Monday night. I would prefer you do it sooner, but it's up to you. I will move the homeworks 3-1, 3-2 till next Friday though. Okay. So we're technically a little bit ahead. So we'll go over derivatives a little bit more I guess we'll go over derivatives a bunch next week. So if it's still kind of confusing, don't worry. We're gonna keep going over it.
Okay,
Right.
I would ask about these problems I attempted to do and somehow screwed up, but for now, yeah, I'll wait until next week and just figure them out then.
Yeah, we can't go over the test just yet.
Yeah. Oh no, it's not the test, it's the homework problems.
Oh, okay.
Problems
I
12
just
through like 15.
before we leave, I just have one last question. If you look at problem number 12 real quick,
12.
you have a smaller y-intercept and larger y-intercept. What does that mean?
That's where I'm stuck.
Because I already worked out the problem, but I just don't know what that means. I kind of want to finish it for the night.
Let me see here. You talking about this one here?
Yeah, it's just
Yeah.
Okay, it says find an equation of a line that is tangent to the graph and parallel to the given. So it's the same deal as what we just did, but it has this extra thing.
That's a cube.
Smaller y-intercept. Yeah, it is a cube. Oh, okay. I think on this one.
okay. I see.
Graph.
I see.
It's a
You
different
see.
graph.
Yeah, I see.
Yeah, you can have two different x values when you
Yeah.
solve for the slope. When you set equal to the slope. So I'll start you off real quick, so you can see what I'm talking about. But let you guys finish it.
Okay, thanks.
Okay, so basically, we're just gonna have two parallel lines, one on the positive side, one on the negative side, right?
Yeah, it's the exact same question. It's just that you have two lines to find instead of one.
Yeah.
And that's because it's cubic. So when you take the derivative, we get 3x squared, right?
16.
And then you solve for the line equation, and you get, I'm going to skip a step here, y equals to 12x plus 1, right? So m is 12, just like before. So you set 3x squared equal to 12. You solve for x by dividing by 3 on both sides, and you get x squared equal to 4. You square root both sides. But you have to tack on the plus or minus. So when you do that, you get x equal to plus or minus 2. So you have two different x's. So you plug in one x into here, and that's going to give you, you get 2 points. You can get 2 comma 2 times 2 is 8, and then -2 comma -8. So you're going to have to use this equation up here twice. One with this point and one with this point, but the slope will be the same. What's up?
Where'd you get 4 from?
Oh, divided by 3. 12 divided by 3 is 4. All right, so solve for x here. Just remember when you square root, you get plus or minus. So plugging it in the -2 and +2 you'll find two different equations.
So that +1 doesn't really matter, right?
No, it
Okay.
doesn't. Technically, it does not.
That was tripping me up. That's
Still a little confused.
Did you understand the last one? This one?
yeah, I got it.
Yeah.
So do the exact same you did here, same thing you did here, but you're gonna have two different x values here.
the reason why you have two x values, or you need to get the two, is because you have the plus or minus two, which comes from the square root of the 4.
Right. So it's because I can zoom in a bit here. Okay. Yeah. So it's because solving for x creates two solutions for the x. So plus or minus 2. So because of that, you plug in positive 2 here, you get 8. 2 cubed is 8, right?
Mhm.
Negative 2 cubed is negative 8. So you're going to use these 2 points and the 12, the slope of 12, to plug into this formula. So you're going to apply it to this formula here twice. To plug in
Okay.
your y1, x1, and your slope, which will be this one. To me.
Okay.
So I'm going to write the formula
So
down here so I have to keep referring to it. So plug in this value into here, x1 and y1, and the slope, and then you solve for y, and you get the first equation. Then you do it again with this point, plug it in here, and the 12, and you get another equation. So you're going to do it twice. So it's the same question, you just do it twice. And they want the one with the smaller intercept, which means this value here, the constant. Whatever has the smallest constant goes first.
Okay.
And the biggest one goes there.
Okay. Let's see.
Great.
See if I can't figure that out.
We're gonna
Yeah.
work next class, or
What's up?
next class, are you planning on working on these or no?
I'll do a couple, but I want you to do the rest.
Okay,
Let's see, like,
I'm working on them during class. I only have 5 left, so not
yeah,
bad.
you should be done by Monday, right?
Tonight.
No, but yeah, if you have questions, of course, we can go over it Monday.
Yeah.
But we will be, because since we're ahead, we can spend some time reviewing homework on Monday and going over any confusion. But do the tests, watch the videos, and try the homework. And please bring questions on Monday, okay?
Mhm.
Because
Okay.
we don't have to move on just yet. We're good.
Okay.
Alright.
For 14, they just square root, right? Like 64.
What's up?
For 14, the one that we're looking at right now, they just square root, right? Like the 64.
They factor the bottom, which is, you're kind of right, but if you do the difference of squares, you'll have x plus 8, x minus 8.
Oh, okay.
But you could set if you set it to equal to 0, and you could do the square root thing if you wanted to. So you'll find the asymptotes that way.
I do have questions already on number 9 and 4. I did it the way you did it for number 4, but I wasn't able to get the right answer for some reason.
Number 4.
So are we supposed to, 3 is the x. We're not supposed to we're not supposed to plug that in right into the function.
Number 9, you said, right? Which one are you looking at? I'm sorry.
4.
Okay, for 4. So here you just take the derivative and you plug in 3.
Oh, okay. That's what I did.
But for this one, you have to take the derivative using the limit property, like you did on number 8. Because you haven't learned the derivative rule for square roots. So use the limit to find the derivative and then plug in the 6. And you'll find the slope thing or whatever number you get. So you have to do it the long way. You have to do it the long way on this one, on number 8 and 9.
I got 8. I just didn't get 9. I'll figure it out.
Yeah, if not, we'll do it Monday.
There's number 12. Okay.
Okay.
Pain in the ass.
Did I see